social distancing, you say? The future is watching. Welcome to OpCode Virtual Summit.
Cool, and welcome back to the virtual summit of OpCode. I hope you guys are having a great time. I see more and more comments in the chat, so that's pretty cool. Thanks again for participating. So far it's going pretty good so far. Thanks also for the feedback. So like I said before, this is the first time I do this. So, and we are live, so like some issues were expected, but feedback is greatly appreciated and more than welcome. If there is anything, Ryan is pretty funny. Yeah, we can shoot one together if you want next time in a data center, you know, like we just look at some laptop and we dress like that, you know, like back when Charlie Miller and Valasek were like going on stage with tracksuits. Oh, cool. I'm glad you guys appreciated the last presentation. Very cool. And again, if you have any like suggestion of talk you would like to see for the next edition, since it's going well so far, like there is 80% chances that we will have a next edition. Yeah, oh, awesome. I'm glad you guys are having a great time, and I'm glad that people from everywhere can watch it also, because one of the problem also I was having with OpCode is every time you're kind of limited with who you can bring, but more importantly who can attend the conference. And it's very difficult to be, you know, to have like a conference where you can actually like attend and get value too, because I mean, now there's so many like conferences that it's very difficult to like pick which one to attend. Personally, I totally stopped to attend conferences because it's just taking so much time, and a lot of the time there is not much value out of it. And even every time I'm in the review committee for a conference, most of the presentation could just be like a blog post, you know. So you're like, okay, like is it really worth going to conferences? So I'm glad. Yeah, some of you are watching like that presentation from your couch, from your bed, from your desk. That's pretty awesome, actually. Yeah, thanks again for attending. And yeah, so we're gonna get our next speaker. So with Charles, and who is based in Nairobi. And let me get that one. So. And yeah, that's should be it. And okay, all good. It's your turn, Charles. I will get the stickers and T-shirts. Yeah, that's a good question. Actually, I guess we could just put them on the GitHub, and you guys could like print them at home. You know, since no one can really go out, and we all have to stay at home. But yeah, so. Yeah, so next speaker is Charles from Nairobi. Thanks again, Charles, for accepting to speak. And yeah, it's your turn, Charles. Let me check if you're properly unmuted. Yeah, I think all good. Yeah, perfect. Awesome.
Okay, guys. So welcome to my talk. It's called Black Box Reverse Engineering, and basically be talking about how I do reverse engineering on SOCs. My name is Charles Muiruri, and that's my handle. I cracked the code. Who am I? I am a security researcher at Azimuth Security. I'm a mentor at a local innovation hub that's called Critical Innovation Hub. I do like ODAs, and I'm deep into vulnerability research, reverse engineering, and exploit development. So this talk will mainly focus, will act as an introduction to most of the guys who want to start doing some reverse engineering, especially on software chips, firmwares. And I will be taking guys through my personal, the steps that I use. And the main agenda will be primarily, we will focus on SOCs. And I have divided the talk into two sections, static analysis, and we later on discuss about dynamic analysis just briefly. So in static analysis, we'll try and understand, or I'll take you through my thought process and how I try and understand, try and gather information about what I'm working on, understand the firmware I'm working on, and try and see how I can load whatever I want, and eventually how I figure out how everything is created based on the tasks. And later on, we'll also discuss why debugging abilities are important and firmware emulation. Again, this is based purely on my personal methodologies in my thought process, and any other approach is still valid, still works. But this is a journey about how me and how I try and think through when reversing stuff. So I basically define black box as anything that is proprietary, closed source. That means I can't find any form of source code out there, and I have zero knowledge on the target, or rather the firmware that I want to look at. I have no understanding of I don't know the architecture. I'm not sure about the loading points. Basically, it's a complete green area, and also lack of symbols, which means that even if you load it straight up into something, into a disassembler like IDA or Ghidra, you still won't understand what's really happening. Then, we have no source code or any leaks whatsoever. So the first thing that I try and do is try and identify sources of information. Now, this is important because you want to gain as much information as possible before you can even, start loading things into stuff like IDA. For me, I always say that that's the last step, because there's so much that has to go. There's so much stuff that you have to do before you actually even load anything into a disassembler. So the first thing that I normally look at is data sheets. I try and understand the chip from an engineering point of view, because that's what data sheets provide you with. They basically give you specifications, and they give you, they are able to answer some technical questions or give you some technical answers, but mainly from an engineering point of view. You might have, a diagram of the board itself, or you might have you might have some information that gives you details about the architecture itself. And that will be important when you in later steps. Then the next thing I try and do is basically try and find platform-related source leaks. And the reason I'm saying platform, in this case, I'm purely making the assumption that whatever I'm looking at has no source code or any leak whatsoever. So the nearest thing to that is a platform leak. In this case, when I'm saying platform, I'm thinking about something like if it's an Android device, like if there is a leaked source code or the kernel source code for that specific device. And this is important simply because it helps me understand how the SoC will communicate with the main processor. In the case of Android phones or the majority of mobile devices, we have the application processor, which is like the main processor. Then we have other chips that do communicate with the application processor. So in this case, you will want to look at these leaks or any kind of source code that you can find out there that will give you some insights, no matter how shallow it is, with regards to how these two will communicate. Then the second thing I try and look at is previous presentations and research papers. Now, this is also important simply because they give you some insights on the topic. They also highlight possible challenges, and this is critical, especially when you want to avoid rabbit holes later on. Simply because you do not want to find yourself looking at a specific area, and you have no idea you end up in a rabbit hole. So for that simple reason, I always try as much as possible to identify challenges within given talks so that I avoid these rabbit holes. Then obviously it gives you a really good head start and helps you get some of the critical information that you might need. Finally, I try and get the firmware itself. Now, this is important because ideally the firmware is actually the source code, or rather it contains the code itself. It could contain various segments, or rather various sections, but ideally what you really want is inside the firmware. So it could contain some strings that might be that might give you some hints and might help you in understand what is happening. But as I personally say that that's just like 1% of the whole thing, because example, you might have a string that is just saying something like pre-insertion something. That does not really give you much information. However, it might give you some small insights onto what happens. Then at this particular stage, through my thought process, I have a challenge, and that is, how will I end up loading this particular firmware onto the chip? And do I have the firmware? And this step is super critical, simply because in some cases you do find that actually getting the firmware of the firmware by itself is a big challenge, and you might have to probably dump the memory of the whole thing, but that is in some rare cases. So once I have the firmware, the next step is now really understanding the firmware. Again, this is all about the thought process, which I believe is critical in any form of research. So there are three main approaches. There are three main scenarios that I have personally observed with regards to firmware headers and their structures. In the majority of cases, you will find like the first few bytes contain some form of firmware header, a small description of the firmware itself. In most cases, they are forming things. There's the size, there's probably the name, there's probably something like the loading address, and there's also probably something like a match. When in some cases you are so lucky and you just realize that the whole firmware starts, the whole firmware just starts from offset 0. So that in such a case, you're lucky because you don't really have to do a lot of the hard work with regards to trying to understand the firmware structure. Then, in the worst case scenario, you have an encrypted firmware. And this could be challenging, especially in scenarios where this firmware is being copied over to, this encrypted data is being copied over to, let's say, a trusted execution environment, and all the decryption is happening over there. And in such cases, you really have to do all the hard work, trying to first of all understand how the decryption is happening. But such cases are rare. However, they do exist. Then the second thing is the other option you could try is trying to reverse the loader, or rather the driver. So in the majority of cases, you'll find that there is a loader that, or rather there's a kernel module that basically loads your firmware onto the SOS, onto the chip itself. And this is done by, this is probably done during the boot stage, during the boot stages of the whole system. Let's say in the case of an Android device, for example, you could have the kernel loading up, having a specific model that just loads up the modem, that copies the modem firmware onto the chip, onto the modem chip, and fires up the modem. And so again, this goes back to the knowledge that we got about how this specific chip would communicate to the main application processor. And in the majority of cases, once you get like this such a kernel module it also helps you in understanding important details such as how the kernel, or rather how things are loaded within the chip itself. Now the next step is, I try and identify the loading address. Now this is important and very critical, because you want to put yourself in the shoes of, as I said, the chip itself. You want to understand how things are being loaded onto the chip side. You want to understand how how the chip sees things, and you can only get a clear view of everything only and only after you properly load everything. And this could be loading it into your favorite disassembler, could be Hydra or IDA, whichever you choose. And this is key because you want to avoid, again, going into wasting a lot of time trying to figure out which is the correct address. And such information could have been provided by the previous step. That is why having a systematic, or rather having a systematic or procedural way of thinking through how you reverse stuff is critical. So in some cases, example in ARM, there are some tricks that you could use. Like you could locate the exception vector table. Yeah, in some cases, there's always a jump to the EVT entries, or it's just on top. This depends. But in most cases, in ARM-based firmwares, once you locate the exception vector table, then you probably have the correct loading address. Now, so at this point, we have the ability to load everything correctly. We have our firmware loaded up well correctly onto our favorite disassembler. Now the next step is simply trying to understand how, once the firmware is loaded, what next? So the firmware has to start a few things, and most SoCs implement a runtime operating system, and this uses a lot of tasks. So in most cases, or rather the majority of cases the majority of firmwares that I have interacted with, always have some form of task creation. Now, tracking down these task creation and functions is critical, simply because they enable you to understand and see where things start from. And the way most firmwares do it is by having task creations for different protocols or core functionalities. We could take the example of a modem. Let's say, for example, it will create a task will be created to handle anything that relates to calls, handle anything that relates to, say, SMSs. And by tracking this, or rather identifying these task creation mechanisms, you will be able to understand a little bit more about the system. Now, strings might be very helpful here, simply because you might have strings that probably give you like error strings, or you might have just simple login strings. I personally categorize strings into main categories, and that is debug strings and log strings. And for me, a debug string is basically any string that provides some form of debug information. Could be an error type, could be a function name, could be like a function, the way a function and its arguments. And the next one is a log string, and this is just something that is just logged. It's from that it doesn't really help with regards to debugging. It's just logged. Could be just an output of the result of something. And the main difference between these two is the debug strings are more verbose compared to the log strings. So you will probably get more information from the debug strings compared to the log strings. And in some cases, you will find that in some firmwares, they will end up disabling the log, anything that I will categorize or will be categorized as just a log string, and enabling the debug strings, or rather the debug prints, simply because it's also useful for their engineers when they are doing, when they are trying to analyze crash dumps and trying to figure out where things went wrong. Now, as I said before, strings might give you just shallow insights to me, and mainly with regards to these systems, or rather mainly with regards to firmwares such as the modems, Wi-Fi firmwares. This is probably just 1%, or rather, to be fair, I would say 5% of the whole thing. And to me, it wouldn't qualify at all as reverse engineering, because there's a lot that you would need to do before you would even, so before you say like this function does ABCD, you need to do a thorough analysis of the function itself. So strings purely, to me, is not does not qualify as reverse engineering. Now, so at this specific point in our thought process, we have everything loaded up. We have identified the tasks. We have identified the task creation mechanisms, and we are at a point that we want to proceed further in our research. And first of all, we need to identify a research surface. In other cases, depending on the purpose of the research, you could also call it an attack surface. But for this specific case, we will call it a research surface. And this is an area of interest that specifically meets your research scope. Could be anything, could be a surface that purely does, an OTA operation, that is an over-the-air operation. Could be anything that is completely remote, or could be anything that is completely local. And this just depends with your research scope, and it has to be in line again with your purpose and your research goals. So sometimes you might find you just bumped onto some really cool surface, but again, when you check and you look at your scope and your goals, it doesn't align. So it's always good to just focus on the goal of your research. Then from there on, the next step is identifying entry points to these attack surfaces, or rather our research surfaces. And these again will be you will be able to identify it based on the results you got previously by identifying task creation mechanisms. And as I mentioned earlier, let's say for example you want to focus on anything that does, let's say, an OTA operation, you will focus on things that require probably zero user interaction. And since you already have discovered that, like let's say call creation is started by this specific task, so you will eventually just narrow down to that specific point. Now, I mentioned debugging abilities. So as at this point, as an add-on, you will probably want some debugging abilities. So this is essential, especially when you want to understand the state of things when a given operation is happening. You want to understand how things look like at a given specific time and points. This is very useful, especially when you're performing memory analysis. For example, you want to understand how your heap looks like when you're doing heap-related stuff, or other memory-related operations. Now, debugging abilities, again, will also be critical when you want to apply things like hooks, which will definitely help you, read stuff probably out of memory in the case that you don't have that ability to read. And firmware emulation. So this will probably be the last step for me. And I only do this in cases where I realize I don't have a device, or I don't have I don't have access to something that is running my target firmware. And firmware emulation is important simply because it tries to answer three main questions, and that is when does something happen? Then why does it happen? You want to know, when does it happen? At what particular point does this function? At what particular point is this function called? Why does it happen? What are the why does it happen? This basically tries to answer the question. What would lead to a given function being called? And finally, what are state of things when it's happening? So this tries to answer the question that of how do things look like when a given operation is done or implemented. Now, at this particular point, I now purely focus on once all of this is done, I now purely focus on bug hunting and vulnerability research. And yeah, and that is the end of my talk, my short talk. Yeah, I think questions are welcome.
Awesome. Thank you, Charles. Let's see if the chat has any question. Quick question while we're waiting for the chat to give one. At how many platforms did you look at for that thing?
So basically, this is my thought process, or rather the thought process that I have been using for quite some time, and I have been using it on a bunch of platforms. I would say when I'm reversing Wi-Fi chip, when I've done Wi-Fi chip reverse engineering with them, and yeah.
And Wi-Fi chips for like routers, this type of thing, or?
No. So this talk was mainly focused on the mobile realm, which is my area of specialization.
Okay. Like baseband stuff, or not necessarily?
Yeah, so baseband stuff. So any chip, or rather any embedded system that is within the phone, that will basically include mainly the Wi-Fi chips and the baseband chips.
Okay. And someone in the chat is saying, I'm here for the exploits. So I guess people are expecting to see some exploits here. Charles, what did you do? Like you're breaking the heart of some people here.
Next time there'll be some, hopefully.
They're like, okay, come on, you're like supposed to represent Kenya. What happened to the exploits?
Hopefully next time.
It's like Stella Magana is saying a quick demo appears. So I guess like people are getting curious. Another question was, are you wearing pants, Charles? From Gabriel Mutange. And one of the question after from Lorna Monyangi is, when doing firmware emulation, can one be able to get the chip specific bugs?
Well, so I think if I understood correctly, is she's asking whether you can find bugs when you're doing firmware emulation. I think I will say it depends, but I don't think you will just find bugs by simply emulating a firmware. I don't think it's possible to just find a bug by running a firmware. You have to actually do some, like code analysis of whatever the firmware itself, so that you can find vulnerability in the firmware. And probably you can emulate, you can use the emulator to try and see if you can hit the vulnerable function.
I see. Yeah, because I know the question was, how does he emulate the firmware? Are you using things like your, what's the name? Is it Unicorn emulator or?
Yeah. So I am a favorite of Unicorn. Yeah.
Cool. Is this the main one, or is there like any other like library that can be used for emulation?
Well, that's the main one that I normally use, I think. But again, it all depends with the one you want to use. But that's the one I'm familiar with mainly.
Cool. Laura Tish is quite enthusiastic. She's like, "Thanks, Charlo, for once I understood everything you said." No floating today. Good one, Charles. Christian Kisutsa is asking if you have any tips for setting up a firmware analysis lab for beginners.
I think one of the main things that you probably need is well, depends with the firmware you're looking at. Probably you would want to set up an emulation environment. If you want to look for some bugs and you will probably want to write a small fuzzer for that too. And I think those are the two main things that you probably need, and also probably an environment that would work with a specific firmware that you're looking at. So, for example, let's say you're working on the base one chip, you probably want to set up an environment that would emulate a base station.
Okay. Another question from Jeziel Spellman. Have you found certain platforms to be harder than others? Qualcomm versus Huawei or Samsung, for example. I guess he's asking for tips of platforms you should look at.
Yeah. So as far as I can tell, all these platforms always end up being different. So in the case that you look at, let's say Samsung, it's completely different from what you will see in, let's say, MediaTek devices, and both of them also are completely different from iPhone devices and Huawei devices. So since all of this, it's usually proprietary, so they are always completely different.
So no platform being harder than others, like for instance, like, because I know like Samsung did a bunch of like security work. They hired a bunch of security people. So like, would you see like more mitigations in their platform compared to like a Huawei, or not really? Because like I guess with firmware, the main problem is like, unlike operating system, where you would see like vendors, like for instance, if you look at Microsoft or Apple, they have like huge team working on mitigations and like bug patching, but many like mitigations where like it changes with each platform. So is there like anything similar with firmware, or not at all?
Yeah, so there's something similar, and so again, the complexity is always different. In some cases, you might find the hardest part is actually trying to get the firmware itself, and in some cases, the hardest part is the mitigations that have been implemented from the in the firmware itself. So the levels of hardness totally depends and totally are different depending on what you're looking at, but it is the same. And I would say, especially for like the last 3 years, or rather the last 2 years, I have seen some major changes and implementation of mitigations into firmwares.
So does that mean they finally have stack cookies to avoid like stack overflows, or?
Yeah, so in some cases you will find stack overflow detection. some cases you'll find SLR implemented. Yeah.
Okay, and let's see if there is any more questions. The presentation. Jaziel is insisting. There was no answer on the Pence question, so I think like the audience is in like really wants to know. Great. Another question. Any hypothesis why MediaTek keeps getting on?
Oh, pardon?
I guess the question keys. I guess it means keeps. Any idea why MediaTek keeps getting owned? Like why? Apparently, like MediaTek, I guess, is having more vulnerabilities than any other platform.
Oh, yeah. So I think, well, this is probably my thoughts. I just think it's because uh, they are not they have previously they were not that security oriented, and that is my thought compared to other vendors, compared to something like Samsung, where in the case that there's a new a patch out, they try and uh, put that, or rather implement that in the next rollout. On MediaTek side, you'll find that there is some delays. There is some, they are slow in implementing stuff. Again, this is based on how I see stuff, so it could be different, but yeah, I think that's the main reason. But that has started changing recently, especially due to more people starting, more people have started to look at the specific area.
And what about MediaTek? Where is it based? Is it a US vendor or Asian vendor?
I think it's an Asian vendor.
Oh, is it Chinese?
Yeah, I'm not sure.
Okay, interesting.
But
okay,
I know
cool.
it's Asian based.
And that's the main firmware being used in Africa, right? If I remember correctly.
Yeah. So the majority of phones do run on the MediaTek platform, simply because I think they provide cheaper. They're cheaper. Yeah.
Okay, that makes sense. Cool. Well, I guess I don't see any more questions. Yeah. Well, thanks for your presentation, Charles, and it was pretty good. Yeah, don't forget to send me your slides after, and then
Sure.
or you can just do a pull request. I think I should just send an email to explain how to do that. And yeah, awesome. Well, thanks, Charles.
Thank you.
Social distancing, you say? The future is watching. Welcome to OpCode Virtual Summit. Indeed. This is a fake background. Yeah, basically the studio is in my bedroom. I didn't really have time to clean it. I was like, you know what? It's probably gonna be easier to just like use a green screen and make it look like I have a clean desk. Otherwise, Nicola, you know better. Like having a clean desk is not a very easy task. Okay, so someone is replying in the chat that MediaTek is a Taiwanese company. Interesting. So they're not Chinese, I guess. Interesting. So NSO has been targeting MediaTek quite a lot. Interesting. You guys have more information than I do on that one. I will not know, but very interesting. I would be interested to know where you got that from. But yeah. Well, I hope you appreciated today's conference. So, like I said, it was the first edition, and I think very likely we're gonna have another one. I was just talking with another like potential speaker. Maybe we'll do like a session, a live discussion on disinformation, because there's a lot of problem with disinformation now, and with the coronavirus. As you can see, it's quite hard to know what's fake news or not, and
even like politicians are kind of struggling, and then you have governments creating their own feeds, and even a lot of that, they kind of relay like some unreliable information. So we still have to decide of the date. It just got decided like, I don't know, like 30 minutes ago with a friend. And yeah, so it should be around disinformation and disinformation. And yeah, so that's it for today. So the presentations are going to be available on GitHub. And yeah, if you have any questions or suggestions, like, you're more than welcome to send me a message on Twitter or send me an email. If you want to speak in the next edition, you can apply. Uh, you can apply to the call for paper, which is still open, and I think it's still gonna remain open. And whenever there is enough presentation, I guess we can kick off another like session. And no, it won't be made into individual videos. Someone was asking. It's just gonna be like the live stream like this being posted, and that's pretty much it. But yeah. Okay. You can message me on your sources. But yeah, that's it for today. Don't forget to subscribe, so whenever we do another live or post another video, you can be aware of it. Yeah, we were around 100 viewers today. I'm quite surprised, to be honest. I would not have expected to have more than 10 viewers, but I guess it's a good surprise. And yeah, since we are all locked down at home and kind of forced to stay at home, because I know some conferences were thinking of just doing like some like volatile studios where like they will invite speakers, but like now most of countries, people cannot even leave their house. So if you have an external microphone, that's pretty straightforward. And yeah, so I guess maybe it's an interesting format that would be that I should keep alive. Yeah, if you think I should do another one, that I should keep it alive, yeah, just drop me a message. And yeah, don't hesitate to recommend that video to anyone after. And yeah, that's pretty much it. So thanks again for listening today, and hopefully see you soon. And yeah, talk to you on Twitter, I guess. Bye.